During World War II, engineers designed thousands of aircraft, and almost all of them looked the same. A cockpit in the center, an engine in the front, and a symmetrical fuselage. But there was one aircraft that looked like it broke all the rules of aviation. The Blohm Voss BV-141. It had the engine on the left, the crew on the right, the tail shifted to one side, and the entire aircraft was asymmetrical. Logically, you would expect such an aircraft to be unstable, difficult to control, and dangerous to fly. But the strangest part is that Luftwaffe test pilots reported the opposite. They said the aircraft was stable, responsive, and very effective for reconnaissance missions. So why was one of the most unusual aircraft in history, an aircraft that actually flew well, built in only about 30 units? To understand that, we need to go back to the year 1937. In 1937, the German Air Ministry issued a requirement for a new aircraft, a tactical reconnaissance plane. The main requirement was simple: the crew had to see everything. For a reconnaissance aircraft, visibility was more important than speed, and even more important than armament. But a conventional single-engine aircraft had a problem. The engine in the front blocked the view downward and forward. The pilot had to constantly tilt the aircraft just to see the ground. There were twin-engine designs, such as the future Focke-Wulf FW-189, but they were more expensive, more complex, and required more resources. The ministry wanted a single-engine aircraft with the visibility of a twin-engine plane. And then engineer Richard Focke proposed a solution that looked radical. The engineer's name was Richard Focke, and he was known for not liking to do things the usual way. Focke had worked in Japan designing carrier aircraft, and he was used to solving complex problems in unconventional ways. He believed that an aircraft should not look familiar. It should look correct from an engineering point of view. When he was given the task of designing an aircraft with perfect visibility, he did not try to improve the classic design. He did something that almost no one had dared to do before. He designed an asymmetrical aircraft. Focke did something very simple. He did not move the engine. He moved the crew. The engine remained in the main fuselage, but the crew cabin was placed into a separate, fully glazed gondola on the right side of the aircraft. Inside this gondola were the pilot, the observer, and the gunner. Visibility became almost perfect. The crew could see down, forward, to the right, and to the rear without serious blind spots. But now a new question appeared. The most important question in this entire story. How can an asymmetrical aircraft fly properly? At first glance, the BV-141 looked like a design mistake. The engine pulls from the left. The crew cabin is on the right. The aircraft should constantly turn to one side. But the engineers calculated everything very precisely. They shifted the vertical stabilizer. They made the wings slightly different in shape. They carefully calculated the center of gravity. They adjusted the control surfaces and trim so that the aircraft compensated for the asymmetry in flight. And then something very strange happened. Geometrically, the aircraft was asymmetrical, but aerodynamically, it was balanced. The aircraft looked wrong, but it flew perfectly. When the BV-141 was first shown to the military, many were sure the project would fail. But then the test flights began, and the pilot reports were unexpected. The aircraft was stable. The aircraft was easy to control, but most importantly, it had the best visibility of any reconnaissance aircraft of its time. For a reconnaissance aircraft, this was critical. The aircraft had to photograph enemy positions, direct artillery fire, and observe troop movements. and the BV-141 was perfect for this role. It seemed that Vogt was right. It seemed that the strange aircraft had won. But then the strangest part of this story begins. 3 aircraft took part in the competition: the Arado AR-198, the Blohm Voss BV-141, and the Focke-Wulf FW-189. The Arado was quickly eliminated. 2 aircraft remained: the asymmetrical BV and the twin-engine FW. The BV had better visibility. It was cheaper. It was easier to produce than a twin-engine aircraft. And based on the test results, it looked like a very strong candidate. It seemed that the winner was already clear. But in military projects, performance is not everything. The FW-189 had 2 engines. The BV-141 had 1. For a normal aircraft, this is just a specification. For a military reconnaissance aircraft, it is a question of crew survival. Reconnaissance aircraft flew over the front lines. If one engine failed, a twin-engine aircraft could return home. A single-engine aircraft almost never could. And in wartime, this was a very important factor. But even this did not decide the aircraft's fate. The engine did. The later version of the BV-141 received a powerful BMW 801 engine. The same engine was used in the Focke-Wulf FW-190 fighter, and the FW-190 was one of Germany's best fighters. At that moment, the engineering story ended, and the story of wartime economics began. Every BMW 801 engine was in high demand. Fighters were more important than reconnaissance aircraft, so the industry made a choice. The engines went to fighters, not to the BV-141. An aircraft that flew well simply became unnecessary in large numbers. The story of the BV-141 is a paradox. An aircraft that looked wrong flew right. An aircraft that passed its tests never went into mass production. An aircraft that was an engineering success lost the war for resources. It did not lose to aerodynamics. It lost to economics, to priorities, to production, and to an engine that was needed for another aircraft. Sometimes in aviation history, the winner is not the most unusual aircraft, and not even the most advanced one. The winner is the aircraft that can be produced quickly, cheaply, and in large numbers. And that is why the Blohm Voss BV-141 remains in history as perhaps the strangest aircraft of World War II.